Broken railway tracks can result from various causes such as wear and tear, extreme weather conditions, improper maintenance, and train derailments. The consequences of broken railway tracks can be severe, including train accidents, delays in transportation, and disruptions to the overall railway network. These incidents can lead to significant economic losses and pose risks to passengers, crew members, and the surrounding communities.
Welcome to Lesson 14 of our Civil Engineering and Railway System series. Today, we're diving into one of the most overlooked, yet critical, aspects of railway design. The invisible forces that shape, bend, and even break the tracks beneath our trains. From temperature-induced expansion to dynamic train loads, civil engineers must calculate everything to keep rails safe and aligned. Think it's just about laying down metal and gravel? Think again. Every curve, joint, and sleeper is a result of careful stress analysis and real-world experience. We'll explore how materials react under pressure, how rail deformation is predicted, and why just one miscalculation can lead to disaster. Whether it's thermal stress, track buckling, or ground settlement, each challenge tells a story about physics, precision, and engineering resilience. So next time you watch a train fly by, remember, you're not just seeing motion, you're witnessing a masterpiece of calculation and control. Hit that like button, subscribe, and get ready for Lesson 15, where we uncover the secrets behind railway switches and turnouts. Railways are the arteries of modern transportation, connecting cities and moving vast quantities of goods and people. But this vital network relies on the integrity of its tracks. What happens when the iron rails themselves fail? A broken rail is more than just a crack, it's a critical failure point. It immediately compromises structural stability, making the track unsafe for train passage. This necessitates an immediate halt to all traffic on the affected line. Detecting these fractures is paramount. Engineers utilize various methods, from visual inspections and ultrasonic testing to specialized rail flaw detection vehicles. Once found, the damage is quickly assessed to determine the severity and required repair strategy. Temporary repairs often involve securing the brake with specialized joint bars, known as fish plates, to allow limited speed passage. However, a permanent fix requires cutting out the damaged section and welding in a new piece of rail. This thermite welding process creates a seamless, strong joint. The speed and precision of these repairs are critical. Every hour a line is closed impacts schedules and the economy. Railway engineers work swiftly and safely to restore the track's integrity, ensuring the network can resume its essential function. Trains, powerful, fast, and seemingly unstoppable. But what happens when the very tracks they run on fail? Broken railway tracks are more common, and more dangerous, than you think. And sometimes, a single crack can lead to disaster. Why tracks break? So, what causes train tracks to break? First, extreme temperature changes. On hot days, rails expand and buckle. On cold nights, they shrink and crack. Second, constant pressure. Trains weighing thousands of tons pass over the same points again and again. Third, time. Even the strongest steel wears down. Add poor maintenance or bad welding, and you've got a recipe for failure. And don't forget natural forces, like floods, earthquakes, and landslides, that can twist metal like it's paper. The consequences. The results? Catastrophic. Train derailments. Explosions. Lives lost. In some countries, broken tracks cause hundreds of accidents every year. Just one fracture can throw an entire system into chaos. Or worse, tragedy. And the worst part? Many of these cracks are invisible, until it's too late. How we fix them? But we're not helpless. Railway experts use advanced tools, like ultrasound scanners, ground-penetrating radar, and smart sensors, to spot damage before it spreads. When a defect is found, the response is fast. Crews remove the damaged section, weld new track in, grind it smooth, and test it thoroughly. Sometimes, the whole repair happens in just a few hours, because every second counts. Broken tracks are a hidden threat beneath our feet. But thanks to innovation and constant vigilance, disaster can be avoided. Next time you ride a train, remember, what keeps you safe isn't just speed or strength. It's the track beneath. Like, comment, and subscribe for more behind-the-scenes looks into the world of railways and engineering. Shaping every stretch of railway track. From stress and strain to stability and safety, this lesson revealed just how much precision goes into every inch of rail. Civil engineering isn't just about concrete and steel, it's about anticipating nature, movement, and time. If you've made it this far in the series, give yourself some credit. You're thinking like an engineer now. Missed any of the earlier lessons? Be sure to check out the full playlist. It's packed with real-world insights, diagrams, and technical breakdowns that bridge theory and practice. And get ready, because Lesson 15 takes us deep into one of the smartest components of railway systems, switches and turnouts. Ever wondered how trains change tracks without stopping? We'll explain exactly how, and why. Don't forget to like, share, and hit that subscribe button so you never miss a future lesson. Got questions or thoughts? Drop them in the comments. We love hearing from curious minds. Thanks for watching, and we'll see you in the next one, where we keep engineering knowledge on track, work so smoothly.